Yes, dear students, I, Rajendra Sharma, welcome all of you once again in session 2 of class 10. And I'm sure that all of you are making good use of this time, which is being spent at home. Right now, in first session, we studied about electric current. What is electric current? How it is measured? What is what is unit of electric current? Right, and in session 2 we are going to study that how to get continuous flow of electric current in a conductor, electric potential, potential difference, circuit diagram, and electric circuit. These topics we are going to discuss in session 2, and I am sure that you will enjoy all these topics. Right, so let's start. Now, in this topic, we are going to discuss how the electric current flow in a conductor. And before this, we have studied that an atom, it is composed of electrons, protons, and neutrons. And out of these three particles, fundamental particles, protons and neutrons are present in the nucleus. And nucleus is like a prison, and these two particles can't come out from a neutron. So electrons they revolve around the nucleus in definite energy shells, and there are some free electrons. Free electrons you are taught in chemistry also. These free electrons are very, very important for us here in physics. Now we know that every conductor means which allow the electric current to pass through it. So inside a conductor there are atoms, and in atoms free electrons are there. And when a conductor is not connected to any source of electricity, any source of electrical energy, then these electrons, they are randomly moving in different directions. So they are moving in different directions, right? So you can see here in this figure they are moving. Their motion is in different direction. So here net flow of electrons through a cross-sectional area, through this cross-sectional area. This is the cross-sectional area of this conductor. So the net flow of electrons in one direction is 0, because the number of electrons going from left to right and from right to left is 0. So we say that there is no flow of electric current in the conductor, which is lying just in front of us, and it is not connected to any source. The conductor means metal wire, copper wire, aluminum wire. Okay, these wires are generally available in our homes also. A conductor metal wire contains large number of free electrons. They move randomly in all the directions between atoms of metals. Net flow of electrons across the cross-sectional area of conductor is 0. This we have discussed in a particular direction, right? So we say there is no electric current flowing in the conductor. So now question comes to us: how can we make electric current to flow continuously through this conductor? To get the continuous flow of this current here through a conductor, what do we need? We need to connect this conductor to a cell. This is the cell here. We can take battery also. We can take dynamo also. Dynamo, some of you must be knowing about the dynamo. Dynamo is a device which converts this mechanical energy into electrical energy, right? So this conductor is connected to this cell. So when this conductor is connected to cell, then what happens? Electrons they start flowing through this conductor. Free electrons start moving or start flowing through this conductor in a particular direction. You can see here these electrons are moving in this direction from B to A, and this is the cross-sectional area. This is the cross-sectional area. So their motion can be seen here in this diagram, right? So here we can see that electrons are moving from this B to A, or we can say that they are moving from this negative terminal to positive terminal. This way this round is completed, and electric current start flowing through the conductor, and we get the continuous flow of the electric current in the conductor. So now here in the cell or a battery, chemical energy is being used. Chemical energy is being converted into electrical energy. Right here. So from this, what do we come to know? When we have to get continuous flow of electric current in a conductor, we have to join it to a source of electricity, and this is here a cell. So to make the electrons to move across a cross section of area, a cell or a battery is connected across the ends of the conductor. Just we have discussed. One end, what happens when a cell or a battery is connected to it? So one end of the conductor becomes positively charged and the other becomes negatively charged, because a battery has one terminal positive terminal, another terminal negative terminal. Here the smaller line is representing negative terminal, and the bigger one is here positive terminal. So one end of the conductor becomes positively charged and other end becomes negatively charged. And now what happens? So when one is positive, another is negative, then its ends means conductor's ends of the conductor, they come at different potential. The positive charges move from the high potential to low. Positive is at high potential, negative is at low potential. So they start moving from high potential to low, and negative charges move from low potential to high. Positive flow from high to low, and negative means electrons, they are carrying negative charge. They start moving from low potential to high potential. Hence electrons start moving with drift velocity from negative end to positive end, and we get continuous flow of electric current through a conductor. Here conductor means, again I am repeating, conductor means the substances, the metals which allow electric current to pass through them easily. Good conductor, the conducting wire which we are using in our home or in industry, here in school, these wires, electric wire, these are made of this copper only. The copper, it is a good conductor of electricity. So here it is now clear that potential difference is must to get the continuous flow of the electric current across the ends of the conductor. Right? Now we are going to next topic here. We have discussed here drift velocity. Now in next, what is drift velocity? And here you can see the two direction of electric current have been shown here. This from positive to negative, and second is from negative to positive. Why these two directions? Right? So now direction of electric current. Before going for direction of electric current, what is drift velocity? So drift velocity is the average velocity which is attained by the electrons in a material. Material means in a conductor due to an electric field. When potential difference is created across the ends of a conductor, then these electrons, they move with the average velocity, which is known as drift velocity. And electrons, they move at the speed of light. Now we are going to discuss here what are the types of directions of electric current. So electric current has now two directions. Here you can see in this diagram, it is written electric flow means and here conventional flow. Electron flow means direction of the electrons are flowing from negative terminal to positive terminal. Negative terminal to positive terminal. We have just discussed here in previous topic. And conventional flow, conventional direction of current, it is not shown here in the electric circuits. We shall be discussing this in electric circuits topic. Here the direction, conventional direction, because when this electricity was invented a long time back, that time we knew about the two type of charges, positive charges and negative charges. But that time electrons were not discovered. So electric current was considered to be a flow of positive charges only, and the direction of flow was taken from positive to negative, positive terminal to negative. So still that is being taken. Therefore we talk about the conventional direction, positive terminal to negative terminal, and actual direction, which is the flow of free electrons, So that is shown here in electric circuits. You can see here this arrow is showing direction of actual direction of electric current, means flow of electrons. These negative charge particles, electrons, they are flowing from this negative terminal to positive terminal here, right? The conventional direction is it is from positive terminal of a cell or a battery to negative terminal, and actual it is from negative terminal of a cell or a battery to positive terminal. So in electric circuits, again here actual direction of electric current is shown, right? Now we are going to discuss a new topic, that is electric potential. About potential we were just discussing here when we have to get the continuous flow of electric current in a conductor. Potential is the word which we use in our daily life also, and some of you must have heard about this. Sometime you must have heard it from your teachers that you have a great potential in you. Potential means it's latent qualities or abilities that may be developed and lead to future success or usefulness. So all of you have great potential, and all of you are going to be very successful in your life. Now if you when we come to physics, it is a quantity which help us to just find out the energy of mass in a gravitational field or of charge in an electric field. Now for this I am taking one example here to explain this electric potential. So first of all, so this is a charge. It is a source charge which has electric field around it, and this electric field is being shown by here positive charge. So this is the electric field. So this area, this is the electric field here. This is the electric field of this source charge, and it is being represented by here capital Q. Now what is the nature of this? It is having positive charge, and this is a field. Means when any other charge, similar charge, if we talk about the similar charge, Q, any other charge means similar charge, comes into this field, enter into this is the circumference, enter into this, then we know that like charges repel each other. So that will get a force of repulsion, the force of repulsion. Now this is another charge, this is the test charge, here it is plus positive test charge, it is being represented by Q. Now we have to bring this charge. So now this charge is coming from this path into electric field here. So when this is coming here into electric field, what will happen? Positive, this is positive field, and this is positive. Positive and positive, what will they do? Repulsion will be there, a repulsive force will act on it. This path, it can come from this side also, so it will experience a force on it. So how do we define this electric potential? So at a point in an electric field, so this point is here, or this point can be here, it can be brought at this point, it can be brought at this point, it can be brought here at this point, is defined as the amount of work done in form of potential energy. Potential means stored energy in moving a unit positive charge. Here we are talking about unit. Unit means one. Unit means one positive charge. One charge is here, not 2, 3, 4. It's one unit charge is there, positive charge. From infinity. Infinity means far away, from outside this field. From infinity, it can be here, it can be here, from anywhere. From infinity to a point in an electric field. So this is the point. This point can be here. This point can be here. Okay. Infinity to a point in an electric field of source charge. The source charge is here. This is Q, and red sign, the red this mark is there. This is the source charge along any path. Along any path without producing any acceleration, means with constant velocity it is coming into the electric field of this source charge. So again I am defining what is electric potential. Electric potential at a point an electric field is defined as the amount of work done in moving a unit positive charge from infinity to a point in an electric field of source charge along any path without acceleration. Okay. Now here what is the formula of electric potential, how it is measured, how we can find out the electric potential at a given point. So it is the amount of work done, okay, or we can say that it is the potential energy, amount of work done upon charge. The amount of work done, it is represented by W, and electric potential by V, and charge is represented by Q, right? So we get this electric potential work done upon charge of V is equal to W upon Q. Now here W is the work done, and we know that unit of work done is joule. and unit of this charge is coulomb. So we get the unit 1 volt. We get the unit of electric potential 1 volt. So this unit has been named after a scientist, right, who invented it, and his name is Alessandro Volta. Alessandro Volta. Right. Now, as to give him honor, so this unit is there. So SI unit of potential difference is volt. It is a scalar quantity. It is a scalar quantity because it has no particular direction. It has only magnitude. So it is a scalar quantity, and it is a potential of the charge body, not the quantity. So it's very, very important point here. You have to remember it is a potential of the charge body, not the quantity of charge present in it, which decides the direction of flow of charges. It's very, very important point. It is the potential of the charge body, not the quantity. How much charge is there? How much? Okay, it's not the quantity of charge present. Which decides the direction of flow. Right? Potential of positive charge body is positive because it is work is done on the charge body, and potential of negative charge body is negative because work is done by the charge body. All right. Now we are coming to definition. What is 1 volt? What is 1 volt? How will you define 1 volt? So define 1 volt here again. I'm taking this example here. You can see. So here this is the source charge being represented by Q, and it has electric field around it. This is positive electric field here, and this charge plus Q is not here written. You can write down in your notebook. So this is the positive test charge. It is coming from this path into this field. So it will experience a force on it. Force will work on it, which will oppose the movement into electric field. So work is done. So electric potential is 1 volt. When do we say it is 1 volt? It is 1 volt if 1 joule of work is done in moving 1 coulomb of charge from infinity to a point in electric field. It's very, very simple. 1 joule upon 1 coulomb is equal to 1 volt. Again, I am repeating, is 1 volt is the electric potential when 1 joule of work is done in moving a unit positive charge, 1 coulomb of charge. Unit positive charge is unit we are taking 1 coulomb charge from infinity to a point in electric field, right? Now next here. Now after electric potential, now difference. What is electric potential difference? Electric potential difference is always between one higher and one lower quantity. So obviously we are getting answer from this. Electric potential difference means difference in potential. So when we talk about the terminals of a battery, ends of a conductor, positive and negative, or two terminals are there. The one is at higher potential, another is at lower potential. Only then electric current flows, okay, through a conductor. So now we are going to discuss what is electric potential difference and how to set it up. How can we set the potential difference across the ends of a conductor? So now here this is the electric field. It is the electric field. You can see it is being represented by E, and arrow showing the direction of electric field here of his source charge. Now we consider a charge. This is a charge Q, only charge, and here it is at position A. So it has some potential energy at this position. It has some potential energy, store energy at this position. Now when we have to move it from this place, we have to move it against this electric field. Then how it is moving? Just see, it is moving. Now it is coming to point B. So now we are going against the electric field. So some work is done. So definitely here the energy will be higher. So at this point, potential energy will be higher than at point A. It has moved from A to B, so it is not being shown here. It has come to this point. So now again I am repeating, consider the task of moving a positive test charge within a uniform electric field. This is uniform electric field because parallel lines are there, uniform electric field from location A to location B here in the diagram. So from this, what we come to know, that potential energy here, it is low and it is high, because we are now going against the direction. We are working against, so more and more potential energy is used, okay, so is required. So potential difference between 2 points and electric field in a conductor. Electric field is set up in a conductor, also in a conducting wire. So in an electric field is defined as a work done per unit charge. Work done per unit charge means on one charge. Unit means, again I am repeating, one. Unit means one. Work done per unit charge in moving a unit positive charge from one point to another. Unit positive charge from one point to another. Here we can talk about the unit charge only also in place of positive. So from this, what do we come to know? This delta V. It's not the triangle, sign of triangle, is a delta. We read in physics delta, difference. So here, change in electric, difference in electric potential is VB. Why we are taking B first? Because at B it is higher and A it is lower. So from higher number to minus lower number. So electric potential energy at B minus electric potential energy at A here upon charge. So this, because we know ability to do work is known as energy. Okay, so here it is written in the form of work done, amount of work done upon charge, and work done is represented by W, and here charge is Q, right? So therefore potential difference delta V equal to VB minus VA, or we can say W upon Q. And in first session we discussed that electric charge Q is equal to I into T. I is the electric current, T is the time. So we can write down in place of this W upon I into T. So here in numerical, sometimes we have to solve, we have to use this formula, right? Now it can be maintained. How it can be maintained across the ends of a conductor? So if potential difference will not be there, then there will be no electric current in the conductor, right? So you should also think it can be maintained between two ends of a conductor by connecting its two ends to two terminals of a source of electric current. Two terminals, every cell, every battery, okay, every dynamo, it has two terminals, okay, positive terminal and negative terminal. So we have to connect the ends of a conductor to these two ends of a battery or cell. So now positive charge flow from higher potential end to low potential, and a negative from low potential to high potential end. This we have done earlier also, right? So if we are using a cell and its potential difference between its terminals is zero, potential difference is zero, so will you get electric current in the conductor? Yes? No. Because no, because there is no now electrical and this chemical energy is left, which can be converted into electrical energy. When you purchase a cell from market, simple cell, it has 1.5 volt. It has 1.5 volt potential difference, 1.5 volt. Right. So when it is being used continuously, and after some it stops working. Now what do we say? Now potential difference is zero. We say that it is a dead cell. Now it cannot give electric current. Right. Now how can we measure potential difference across the ends of a conductor? So ammeter we have discussed. Ammeter, A for ammeter, A for ampere. Ammeter is used to measure the ampere, means electric current passing through a conductor. And here when we have to measure potential difference, because it's a unit we have done, it's volt. So here voltmeter is used. Voltmeter means it measures the volt. Volt means it measures the potential difference across the ends of a conductor. Right, and what are the properties of this voltmeter? So an ideal voltmeter should have infinite resistance. It should have infinite resistance. It should not allow the electric current. Okay. So it should oppose the flow of electric current through it. So it measures the potential difference in volt. Voltmeter of minimum least count. If we are talking about minimum least count, minimum means if we are taking minimum least count, voltmeter of minimum least count means it can measure, yes, very small amount of current, here potential difference across the ends of the conductor. So this means if it will give you accuracy. It will give you accuracy. So we should prefer this voltmeter, okay, with minimum least count. But while using this voltmeter and ammeter, we should take some precautions. We should be very careful. Ammeter, if you try to recall, is used in electric circuits in series. Okay, series, because it is allowed to current passing through it. It has to measure the electric current passing through it, right? But here voltmeter, it should never be connected in series. Now it's a good question for competitions, right? So why it should not be connected in series? Reason being, it has high resistance. Resistance is high, which will not allow electric current to pass through it, and it will not give correct reading, right? So it should never be connected in series. So resistance is very high. Resist means to oppose. Resist means to oppose. So it will oppose the electric current. Okay, in series, electric current will pass through it and will try to pass, but it will oppose. So it will not give you correct reading. So now, what is least count of voltmeter? If you try to recall, a meter we have done. Now same way for voltmeter we can do, right? So this is a voltmeter. It's written here V. Now two terminals are there, and this is the needle. Now this is a scale of a voltmeter. And what is the range here? Yes, the range is here. It's starting from 0 and it is 3. So what is the range? The range means between this range word. Sometime what happens? When we go to market, if you are buying clothes, so sometime a shopkeeper asks you, so what is the range of this buying the clothes? So you tell me, you tell him, show me clothes between 2,000 to 4,000. So lower to 2,000, not below 2,000, and above range is 4,000, not above 4,000 rupees, right? So here lower is here 0 and here higher is 3. So range is here 0 to 3. What 0 to 3? Is it complete sentence? No, 0 to 3 volt. It's not complete. 0 to 3 volt here, right? Now next we are coming same, you can see here now least count formula same, range of voltmeter upon total number of divisions. So range is here 0 to 3. 3 minus 0, what do we get? 3 minus 0, 3. And how many number divisions are there total? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 10, 10. And here 5, 15, and 5, 20 divisions. So between 0 and 3 means here on this scale 20 divisions are there, right? So its least count is 3 upon 20, and 3 upon 20, what do we get? 0.15. How to get 0.15? So use mathematics, simple mathematics. Convert 20 to nearest 100. So 20 into 5, we know 20 into 5, 100, and 5 is also multiplied with this 3. So 3 into 5, 15, and 20 into 5, 20 into 5 makes 100. So here 15 upon 100 means 0.15 volt. So this way you should try to calculate the numericals, try to solve the numerical. Go for simple use of mathematics, rules of mathematics, right? Now, reading of voltmeter, how do we read it? How do we read? Here, how will you find the reading? Needle is here. So how will you read? What is the reading of this voltmeter? What is the potential potential difference being measured by this scale, by this voltmeter? So reading of voltmeter is equal to number of divisions shown by the pointer. You can see here pointer. It is at 10, 1 11, and 1 12. It is on 12 into least count. Least count we have done 0.15. Now try to solve it. Yes, I am giving you some time. Yes, doing. Yes, some of you must have done. Now it comes out to be how much? 12 into 0.15. 12 means here total 5 plus 5, 10, and these 2, 12. least count is 0.15, 0.15. I'm not saying 15 because point after 0.15. So 12 into 0.15 is called, it comes out to be 1.8 volt. The reading of this voltmeter is 1.5 volt. So this way we can get this reading of voltmeter. We can read voltmeter. Now characteristics of voltmeter again. It is always connected in parallel combination in electric circuits. Very, very important for MCQs. Positive terminal of ammeter should be connected to positive of cell or a battery, and negative of it to be negative of cell or a battery. Simple. Reason, because it is because potential difference refers to 2 points. Potential difference means higher and lower. So to measure the potential difference between 2 points in a circuit, we connect the 2 terminals of the voltmeter to these points, right? And it should have a high resistance. We have done earlier. Again, it is being repeated here. And it should have high resistance to allow a negligible amount of current, because it has to measure potential difference, how much work is being done from one end to another. So it should have high resistance, not to allow electric current to pass through it. Electric current, current word is important. Current means flow, continuous flow, right? So now how it is connected, you can see here. Voltmeter is coming, is positive, negative end. Now one wire is connected, another wires to another terminal. Now this way the circuit is completed. Now you can see here this is parallel. This is the conductor, right? If this voltmeter is connected here at this point, then it will be in series. And here this point A is there, this point you can write B. So it is measuring the potential difference across its end A, and here this end is B. So therefore this way voltmeter is connected in electric circuits. Now galvanometer, that's the last topic of this, galvanometer. Galvanometer is a device which is used to detect the it is used to detect very small amount of current in the circuit. In next chapter, electromagnetic induction, I shall show you an activity in which you will see a galvanometer. It works on the principle that when current flowing through a rectangular coil is kept in a magnetic field, it is deflected. Right, that coil is deflected. We shall be doing in next chapter. Galvanometer can be converted into ammeter and voltmeter. It's again important point for competitive exams. Into ammeter, how can we convert? A galvanometer can be converted into an ammeter by connecting a low resistance called shunt resistance parallel to the galvanometer. This way we can convert. And how can we convert into voltmeter? Simply you have to remember, it can be converted into voltmeter by connecting a high resistance in series with it. So in voltmeter, resistance is connected in series, but voltmeter itself is connected in parallel. And here ammeter, and this shunt is connected in parallel, but ammeter itself is used in series. Now this is the galvanometer. Here needle is at center. Needle of galvanometer is always at 0 because it can deflect this side, it can deflect this side. When I discuss next chapter, you will see how this movement is taking place in the galvanometer. An activity I shall show you, right? So because current can flow here in both directions when we move a magnet into the coil or outside the coil, right? Now these are some symbols of electrical devices. Here you can see these symbols are very, very important. So this is electric cell, this is battery, plug key, or switch, or now here it is open. Here it is open means no current is passing. When this here it is closed. Here this point it's showing that key is closed and electric current is passing through the circuit. Now this is joint wire. A joint is there in the wire. 2 wires have been connected. Wire crossing without joint, electric bulb, This is the resistance we shall be using in electric circuits. Now variable resistance, in Ohm's law you will be using it. It's right. Now a meter we have done, voltmeter. Now what is a circuit diagram? The circuit diagram, circuit word is from circle. Circle is always complete, not broken from anywhere. It's a complete, right? So circuit diagram, we use ammeter, voltmeter, we show them like actually when as they are, but it's very difficult to make actual ammeter, voltmeter, then resistance or this rheostat. So we use their symbols. So a diagram, circuit diagram, what is circuit diagram? Means circuit means complete circuit. So a diagram showing the arrangement of various electrical components. Various electrical components, we have discussed the symbols in an electric circuit with the help of their symbols is known as circuit diagram. So electric circuit, what is electric circuit? Circuit. I told you that circuit is from circle. The circle means closed. So electric circuit is a closed path. It's not broken from anywhere. It's no wire is broken from anywhere. Key is closed. Okay, terminals are conductors are connected to terminals. It is a closed path of flow of electric current from one terminal of a source of electric current. It may be cell or a battery or any other source to the other terminal through various electrical components. Here you can see. Here components are voltmeter represented by symbol V, ammeter plus and minus. A cell direction of the current is actual direction of the current. This is the resistance, and here it connecting wires. So this is circuit diagram. You should practice it. Circuit diagrams are very, very important, right? You can see here how voltmeter is connected. It is connected in series or parallel. Yes, series or parallel. Yes, sound is coming to some of you are giving answer. Yes, it is parallel, and here it is in series. Now you can see plus is connected to plus, minus, and here minus to plus, and again the negative terminal of voltmeter is connected to negative of battery. So this is the complete circuit diagram. Okay. Now thank you very much, and I'm sure that you must have understood what we discussed today. And now keep saving water, keep making your environment clean, and at last I shall like to say, stay kind. It makes you beautiful. So if you want to be beautiful, stay kind. Okay. Now thank you very much once again, and God bless you all.